All right, so I'm making this video to help you guys out with your delta math. I pulled these problems from delta math and just changed some of the numbers in them. So they'll follow along exactly like what it is that you guys need to do. So this says the radius of a cone is increasing. So that's dr dt. It's going to be positive since it says increasing. And I'm not really going to worry about units for this because on delta math, it puts them for you anyway. So I'm just going to go ahead and put 4. So dr dt is 4. Volume is decreasing, so dv dt is going to be negative 20. Now we're going to pause. It says at the instant when the height is 24, so height is 24 centimeters, and the volume is 130 cubic centimeters. What is the rate of change of the height? So dHdt is the question mark. And it says that the radius is getting bigger and the volume is getting smaller. So it's kind of hard to determine what's going to be going on here, like positive or negative. So I'm just going to kind of leave that off there. So we are talking about volume of a cone. So if you pull out your formulas here, volume for a cone is right there. So we've got volume equals 1/3 pi r squared h. Now I'm going to need to, I think, get rid of, or no, I don't need to get rid of r because I have dr dt. I was about to say sometimes you need to substitute one or the other of them out if you don't have any information, but I do have information about r. So we're going to go ahead and just do our derivative. dv dt equals, and it's going to be a product rule. 1/3 pi r squared is the first thing. H is the second thing because I have two separate variables. 1/3 pi is just a coefficient. Remember, pi is a number, so that's sort of just there. But we have two different variables. So that's why it's two different things. So it's going to be the first thing times derivative of the second. Derivative of h is dh dt plus the second thing, and then times derivative of the first. So if I bring this 2 down, it's going to be 2/3 pi r. This 2 will drop to a 1. So r to the first, and then dr dt. I'm not sure why I used brackets instead of parentheses there, but whatever. I guess that's what I decided to use. All right, so now we're going to plug things in, and I think we are going to be missing something because we don't have r. We have dr dt, but we don't have r, so we probably are going to be missing something here. So dv dt is 20 equals 1/3 pi. I'm just going to write that as pi over 3 r squared. I don't have r, so I'm going to leave that blank right now. We'll have to come back. dh dt is what we're looking for. H is 24. And then we have 2/3 pi. Again, r I don't have, and dr dt is 4. So when you are missing something, you go back to the original relationship, plug in what you have, and look for what you don't have. So we're told the volume is 130. So I'm going to plug in, this is just like a margin problem, all right? I'm going to have 130 equals 1/3 pi r squared. H is 24. Right over here in my list. So I'm plugging in what I have, solving for what I don't have. So 1/3 of 24 would be 8. I'm going to divide both sides by 8 pi, and then here's where the calculator is going to come in. So I'm going to type 130 divided by 8 pi. That gives me that. And then to get r by itself, we would have to square root. So I'm going to square root that number. So that's r. Now, here's the thing. You can't round off to 3 decimal points yet. If you do that, when you recopy this number, it's like telephone game. When you recopy that number into these blanks, you're recopying a rounded off number. And so your final answer isn't going to be accurate enough. So you can't round off until the very end. So now I have to unbury this dh dt and pretend I've just copied that into these blanks. That 2.274 blah, blah, blah. That's what goes right here for r. So what I'm going to need to do is subtract this over. So I'm going to do 20 minus all of this. That'll get this term by itself, and then I'll divide by this pi over 3 r squared. So again, more in the calculator. Here's what I'm going to put. 20 minus, and then I have to subtract all of this. Let me see if I do a little bit of this in my head. 24 divided by 3 would be 8, times 2 would be 16. So it would be 16 pi times that r number, which I think I can just go back and get that, can't I? Yeah, there we go. And times 4. So I'm subtracting all of that over. That gives me that. And then I'm going to divide by this pi over 3 r squared. So I'm going to divide by pi over 3. And then that r number squared. And then this would be your final answer. And so that's what you could round off to the 3 decimal points. And we truncate, but in deltamath, it says to round to 3 decimal points. This one did not round up because 4 won't round up the 8. But if it did, like say that was a 5 there, you'd have to put 0.729 because they do round. So you can't truncate these. So it is a lot of annoying button pushing, but you know, there's a lot of annoying button pushing on the AP exam. So it's good practice for you. You got to be able to get through it. All right. Area of a circle is decreasing. So that's dA dt. And because it says decreasing, it's going to be negative 110. Again, I'm not going to worry about the units because when you type it into deltamath, you won't need to worry about that. All right, so at the time when the area is 4 pi, what is the rate of change of the circumference? So dc dt is our question mark. So I'm going to come back over to my formulas. Oh, actually, I didn't print these ones. Oh, no, I did print these ones on there for you. I did put a circle on there for you. I think it was the rectangle I didn't put on there, but I did put circle. So we need area for a circle and we're going to need circumference. Actually, we're going to need both of them. So area is pi r squared. And so I'm going to do the derivative of that. dA dt would be 2 pi r dr dt. And then I'm going to plug in for what I have. So dA dt is negative 110. 2 pi, I don't have r. Actually, and I don't have dr dt either. So I think we're going to need to solve for dr dt. I can get r though. If we go back to the original equation, I can plug in my 4 pi for my area. So again, this is going to be like a margin problem. So 4 pi equals pi r squared. The pi's are going to cancel. If you square root both sides, we get that r is 2. So I can fill that in. Now, I know this feels kind of like, where are we going with this? Like you're solving for dr dt, and that's not what we need. But trust me, we're going to need that to answer the other part of the question. So kind of just like trust the process. So this would be negative 110 equals 4 pi dr dt. And then I'm going to divide by 4 pi. So clear all this out. We've got negative 110 divided by 4 pi. So that is our dr dt. And again, you're going to need all the decimal points. You can't, round it off until you get to the very end. So now I need to do circumference because we're looking for the rate of change of circumference. So if you look at circumference for a circle is 2 pi r. And so I'm going to do the derivative of that. dc dt equals 2 pi dr dt. And so this number is going to get plugged in for dr dt. So basically, we did this first problem to find dr dt, and then you're going to plug that in down here. So my answer is going to be 2 pi times this number. And so that, it came out to negative 55. All right. Volume of a sphere is increasing. So that's dV dt. It's going to be positive since it's increasing at a rate of 5,000. They give such big numbers here. Again, I changed them a little, but I tried not to change them a whole lot because I want this to really be comparable to what you're doing on deltamath. At the instant, we're going to pause, when the volume is 1,020 cubic centimeters, this is your question mark, rate of change of the surface area? So ds dt is our question mark. It should be positive because if the volume's getting bigger, the thing's growing. So we're going to need both volume of a sphere and surface area of a sphere. So if you go over to your formulas that I gave you, we're going to start with volume because that's the one we have information about. So volume equals 4/3 pi r cubed. Going to do the derivative. When you bring the 3 down, they'll cancel. It'll just be 4 pi r squared dr dt. So dv dt is 5,000. I do not know r, and I do not know dr dt. This one's going to be similar to the one we just did. We're basically going to solve this volume problem to get the rate of change of r, dr dt, and then when we do surface area, we'll have that number to plug in. But I'm also missing r, so I'm going to go back to the original problem, plug in my volume was 1,020. So to cancel out the 4/3, we're going to multiply by 3/4. So I'm just going to type that in. That gave me 765 equals pi r cubed. I'm going to divide by pi. I guess I should be showing you this. I just typed in 3/4 times 1,020, I got 765, and dividing it by pi, I got that. And then I need to do a cube root. So that's in your math menu. And I get cube root of this number, and that is r. 6.244588892. So that is what's going right here. So to get dr dt by itself, I'm going to do 5,000 divided by all of this. So divided by 4 pi, this r number squared. So I did 5,000 divided by all that, and that's my dr dt. And again, it's kind of like, why are we doing this? That isn't the number that we want. Sorry, I can't talk and write this at the same time. But we're going to need that to answer the next question. It's like a 2-part question. So now we're going to do surface area. So let me pull out my formulas. Surface area for a sphere is S equals 4 pi r squared. We're going to do that derivative. So when you bring the 2 down, it's 8 pi r dr dt. And we're going to plug in this number for r, this 6.244 number, that's our r, and then this 10.203 for dr dt. So let me just pull that all in the calculator here. It'll be 8 pi and then times r. So let me go back up and get that. That was the 6.244 number, and then times dr dt, which is that 10.203 number, and then that's your final answer. And so you can round that one off. So that'd be 0.386. Again, lots of very annoying button pushing, but they're going to do that to you on the AP exam too. So I don't want to like not have you practice it. Just, trust the process. All right. And then last one, volume of a cube is decreasing. So that's dv dt, and it's going to be negative since it said decreasing. So negative 500. At the instant when the volume is 160 cubic meters, what is, this is your question mark, rate of change of the surface area? So this is again going to be a 2-part problem. You have volume and you have surface area. So volume of a cube, I did put that on your list here. But I mean, length times width times height, but the length, width, and height are all the same thing. So it's just x cubed. So volume is x cubed, or whatever letter of the alphabet. Some people use S for side. I don't like S because it looks like a 5. So anyway, X is what I used there. Do the derivative. That's going to be 3x squared dx dt. Our dv dt is negative 500. We don't have x, and we don't have dx dt either. So again, we're going to solve this first problem, get dx dt, and then we're going to use that to answer the surface area question. So if you're missing something, you go back to the original relationship. Our volume is 160 equals x cubed. And actually, you would just cube root that. So I'm just going to put cube root of 160. You could type it in and get a decimal as well. And then to get dx dt, you're going to divide all that over. So it is going to be negative 500 divided by 3, and then cube root of 160 squared. So we're doing negative 500 divided by all of that. So this is our dx dt. All right. And then I'm gonna get my surface area for a cube, which one side of a cube would be x squared, and a cube has 6 sides, so that's why it's 6x squared. And then do that derivative, ds dt is 12x dx dt. And then we're gonna plug in. So what did we find? X was cube root of 160. And then dx dt is that big decimal here that we got in the other problem. So I'm just gonna type all that in. So it will be 12 times cube root of 160 times, let me go and get that number. And there we go. So again, your deltamath, I got these problems from deltamath, and then just tweaked the numbers a little bit so that they were different. So your problems will follow along exactly like these. If you're using Desmos because you don't have one of these calculators, I mean, fine, I guess, but you won't be able to do that on the AP exam. So you're going to need a TI-84 to take the AP exam because they won't let you use Desmos on that.